The main function of a fire pump is to increase the pressure of water that flows through it. Common types of fire pumps include split case pumps, vertical shaft turbine pumps. The engines or motors used to turn the pumps are called pump drivers. Drivers commonly are powered electrically by diesel engines or steam turbines. Pump controllers which control pump operation vary according to the type of pump driver. A pump installation's components and accessories consist of piping and fittings, relief valves, circulation relief valves, test equipment, pressure maintenance pumps, and gauges. Fire pumps should be thoroughly tested when they are installed and should be regularly inspected, maintained, and service tested thereafter by qualified personnel. Fire pumps as described are used to increase water flow and pressure for fire suppression. As an example, a high-rise building that is sprinklered would not have enough pressure from the municipal water system to reach the upper floors with adequate pressure to effectively operate sprinkler heads. Therefore, a pump may be added to the system to augment that pressure. Split case pumps are pumps whose housing comes apart in the middle for repair. The pump in a fire engine is considered a split case pump. Horizontal or vertical refers to the orientation of the impeller shaft. Therefore, the pump in your engine is a horizontal split case pump. Because the impeller on a horizontal split case pump is not fully submerged in water, it will require either that it is primed before use or that the supply be under pressure. This type of pump would be used to augment a municipal water system that is either inadequate in flow or pressure to perform at the standards required by an occupancy protection system. Multiple stage pumps can channel the water from the discharge of one impeller to the intake of the next, developing much greater pressure without overworking the power source. In your apparatus, a multiple stage pump can flow larger amounts of water through smaller impellers. This reduces the amount of power necessary to turn the pump, allowing for greater discharge on a smaller system. Vertical split case pumps are similar to horizontal split case pumps in that the case comes apart for repair. However, in vertical pumps, the impeller shaft is mounted vertically. Furthermore, the drive motor may be mounted on top of the drive shaft vertically to save floor space in a small pump room. The pump is used where the supply is not pressurized. The impellers are fully submerged in the water at all times, so priming is not necessary. It may be installed over a cistern, in a well shaft, or in a river. The driver is the mechanism that turns the pump. The pump is required to turn at a certain speed to produce a predetermined flow and pressure. Therefore, the driver must be of sufficient power to turn the pump accordingly. Electric and diesel engine drivers are definitely the most common driver today. Gasoline engines are no longer allowed due to the lack of reliability caused by the ignition systems. Electric drivers shall have a redundant power supply so that if power is lost to the building, the pump will continue to operate. Electric drivers require very little maintenance in comparison to diesel drivers. Diesel engines are the most dependable internal combustion drive mechanism for a fire pump application and have the advantage over electric drive motors in that they don't need external power source for operation. However, for a vertical shaft pump, a gear drive is required to change the angle of drive from engine to impeller shaft. One advantage of using a gear drive is that a gear ratio may be used to attain proper pump speed without running the engine too slow or too fast. Diesel engines are required to have engine system monitoring and battery maintenance equipment to ensure proper operation. Fuel storage and the amount of maintenance that is needed for a diesel engine, in contrast to the low maintenance needs of an electric motor, are detractors of the effective diesel engine. You will likely not see a steam turbine pump driver over the life of your career. The need for an uninterruptible source of steam makes them impractical. The pump controller is the system of sensors and switches that starts the pump in the event that is needed to perform. In addition to automatic starting the pump, it has provision that will allow manually starting and stopping the device for purposes of maintenance and weekly check operation. The controller is usually located in the pump room near the pump in a red cabinet. A controller for a diesel engine is not the same as a controller of an electric motor. While our tasks may be similar, the way they function is distinctly different. In addition to starting the driver for a fire pump, the diesel controller is a system used to monitor critical functions of a diesel engine and to send an alarm to a monitor if a critical function fails. Pump's installation is a careful choreography of equipment designed for the occupancy and the hazard. Once a system is designed and installed, participating in or observing an acceptance test is a great way to become familiar with a system and its operation. For occupancies that are protected by a pump system, careful consideration needs to be made when the occupancy undergoes a change of use. Change of use may require configuring a system to protect the new hazard. Relief valves used to be installed to prevent overpressurizing the system in the event the driver ran too fast. Relief valves on fire pumps are now required if the pump pressure is enough to damage the system components while at churn. Churn is when the pump is running, but all discharges are closed. Size of relief valves and piping is determined by the pump capacity rating. The relief valve should be set to open at a pressure slightly higher than operating pressure.